morning all, my name is Kyle Herman and this is my presentation on spectroscopy of simple molecules. What I will be discussing in this presentation is the purpose of the experiment we conducted, the RIR and the NMR spectra, the experimental steps that we took, and the practice that we had with unknown compounds, the results, and the conclusion. So, acquiring skill, the spectroscopic techniques that we picked up in lab were the IR spectra and the NMR spectra. The IR being infrared spectroscopy, which is triggered by an increase in molecular vibration or the vibration of the bonds, which will tell us the functional groups present in a compound. The nuclear magnetic resonance spectra, which is the excitation of hydrogen molecules, which will tell us how many different kinds of hydrogen molecules are in a bond. So the IR spectra will normally fall in these ranges when you look at a graph and you see absorptions between these ranges. This functional group will be present. An example of this is ethanol. So it has a peak value of 3358, 3,358, and that is of the inverse centimeters. And that indicates an O to an H bond up here. And then it also has a peak value of 2,974, which indicates a carbon singly bonded, a hydrogen singly bonded to a carbon. This is also the NMR spectrum of ethanol, and it has 3 peaks, which indicates 3 different kinds of hydrogen. It has the OH here, the CH2, and the CH3. So the NMR spectrum will give us the different kinds of hydrogens and therefore the ratio of the areas. So for the experiment, we first practiced identifying functional groups in the Lewis structures, and then after that we predicted NMR spectrums using the different kinds of hydrogens that we recognized in the Lewis structures, and then using the techniques that we picked up, we identified unknown compounds that we were given. So, for an example of the functional groups that we identified, we would be given a Lewis structure, H3C, CH2OH, which is ethanol. And we would have to recognize that it has an OH bond here and a CH bond, singly bonded carbon, here and here. So then we would then look at the Lewis structure to predict the NMR spectra. We would look at the different kinds of hydrogen to predict the number of peaks and the ratio of areas. Again, I used ethanol, and we could see that here there's a CH3, a CH2, and then an OH, therefore bringing us 3 peaks and a ratio of 3 to 2 to 1. Identifying unknown compounds using the techniques we used, I was given 3 unknown compounds, and this is one of them, 21G. And this is the infrared spectra of that compound. On the x-axis is the frequency in the inverse centimeters, and on the y-axis is the percent of T, or light. The different peaks that I identified on the infrared spectra were a CH singly bonded carbon here with a value of 2,957, and C double bonded to an O with a value of 1,747. The NMR spectra for 21G showed 2 peaks, each with a value of 1. So with the information that I gathered from the infrared spectroscopy with the peak values, I was able to narrow it down to 4 compounds here. And then with the nuclear magnetic resonance spectroscopy having 2 peaks, I was able to knock out this one because it has 3 different kinds of hydrogen, as well as this one because it has 2 different kinds of hydrogen, but it would show 3 peaks. And then acetone, I was also able to rule that one out as well. This is the information that I gathered, organized in charts, and the winner is methyl acetate due to its 2 peaks and the correct functional groups. It had the two peaks that it had consisted of two CH3s, but they were different in that CH3 over here was bonded to a carbon, and the CH3 over here was bonded to an oxygen. And that is the conclusion I came to with the anode compound. And those are my references.